Hi everyone, I'm Feross, and I'm honored to be here. Thanks for coming to my talk. It's a jungle out there. Open source supply chain attacks. First, a bit about me. I'm an open source maintainer. I started WebTorrent, which is a peer-to-peer file transfer protocol, and StandardJS, a linter that catches programming errors and enforces code style. I've been doing open source since 2014, and I've created over 100 NPM packages that are downloaded 500 million times per month. You probably use some of my NPM packages somewhere in your dependency tree. In the past, I was on the Node.js board of directors, and now I'm the founder of a security startup called Socket, and a visiting lecturer at Stanford University, where I teach web security. Let's talk about npm install. So npm install is amazing. It's the gateway to 1.7 million wonderful packages. And the npm registry made the development process so much more efficient, and it created a large community that collaborates and shares open source code. In short, npm revolutionized the way that we do JavaScript. It's the reason that we can get an app off of the ground in hours and days instead of in weeks or months. And it's the reason that you don't need to be an expert in cryptography or time zones or the virtual DOM to build a powerful and performant modern web app. 90% of the code in your app was written by volunteers. All of modern digital infrastructure uses open source. And some of that infrastructure depends on a random person in Nebraska who has been thanklessly maintaining it since 2003. Nearly everyone in the world directly benefits from open source, whether they've heard of it or not. And maintainers deserve our support, our funding, and our eternal gratitude. So who are these people? Who are these maintainers? Well, all of them are lovely people. Well, most of them anyway. And I don't mean that some of them are grumpy or mean some of the time. Some of them are actually outright malicious. That's because criminals and thieves and miscreants have found a way to infiltrate our community and infect popular packages with malware. They insert code that steals credentials, installs backdoors, and abuses compute resources for cryptocurrency mining. We've seen top organizations with great security practices get infiltrated, no matter how well defended or well funded. And we see new headlines like this every few weeks. It seems that if you rely on open source software, then you're vulnerable. Just a week ago, UA parser.js was compromised. This was huge news. This is a package with over 30 million downloads a month, and it's used by thousands of other packages. What happened here was an attacker uploaded a version of it with malware that stole credentials and mined cryptocurrency. So every time I see these headlines come across my screen every week, I ask myself, why does this keep happening? I think part of the reason is that what we're trying to do is kind of crazy. We want to download code from the internet written by unknown individuals that we haven't read, that we execute with full permissions on our laptops and servers where we keep our most important data. It's a miracle that this system even works. And it's a miracle that it's continued to mostly work for this long. Part of the reason is most people are just good, I think. But another part of it is that we try to be a little bit careful when we pick our dependencies. I think most people, most companies have a process for picking dependencies. This is the process that I kind of go through when I'm picking a dependency. Usually I check, does it get the job done? Does it have an open source license? Does it have good docs? Does it have lots of downloads and GitHub stars? And then, does it have recent commits? Is it a healthy project? And, most of us probably stop here and we'll just, start using a dependency at this point. Maybe if you have a little bit more time, you might check, does it have types or tests? Does it have a low issue count? Are there multiple maintainers? And maybe if you have even a little bit of extra time, you might even open up a couple of the files and take a look at the code and see if it looks reasonable. But the thing is, the truth is, very few of us have actually read the code of the packages that we're shipping in production. And there's a problem with this. There's a huge problem with this. If you ship code to production, you are responsible for it. There's just no way around it. The most popular open source license, the MIT license, literally says as much. It says open source is provided as is without warranty of any kind, and in no event shall the authors be liable for any claim, damages, or liability. So, this is ultimately our responsibility as people deploying code into production. We're responsible for what we put in production. And so given this, you might ask yourself, how can I protect me or my company from supply chain attacks? Recently, I've been asking myself the same question. The company that I started built a product called Wormhole, which lets you share files with end-to-end encryption. Our goal was to build the most secure and private way to send files. And so, our team does all the usual things. We think about security early in the design process. We write tests. We enforce code reviews. And we think we're pretty thoughtful about which dependencies that we decide to use. But this is a hard problem. This is just hard. We have a lot of packages flying around. And, a 2019 Usenix paper found that installing an average NPM package introduces an implicit trust on 79 third-party packages and 39 maintainers, creating a surprisingly large attack surface. And the thing is that we're a small team, so when adding a new dependency, we can't really afford to manually audit 79 packages. There's just no time. And this is true on almost every team. So, we rely on Linus's law, that given enough eyeballs, all bugs are shallow. So if there's a security issue or malware in an NPM package that we rely on, we just hope that others find it first. But the thing is, if everyone does that, who is finding the malware? Maybe that's why a 2020 paper found that on average, a malicious package is available for 209 days before it's publicly reported. That's 209 days during which the wrong npm install command or a typo that you make can end extremely badly. I personally find this number quite shocking, and I really couldn't believe it. But a 2021 paper at NDSS, a prestigious security conference, found similar results, including that 20% of these malware persist in package managers for over 400 days and have more than 1,000 downloads. So, maybe that's why the EU Agency for Cybersecurity predicted that 2021 would see a fourfold increase in software supply chain attacks. It really saddens me to say it, but it seems like this problem is only going to get worse based on the data of the last few years. So maybe it's worth taking a minute here to distinguish between vulnerabilities and malware, because they're very different. Vulnerabilities are accidentally introduced by maintainers, by the good guys, and have varying levels of risk. Sometimes it's okay to intentionally ship a known vulnerability to production if it's low impact or it's not possible for an attacker to actually exploit it. And even if you have vulnerabilities in production, they may not be discovered or exploited before you update to a fixed version, so you have some time to address them. Malware, on the other hand, is quite different. Malware is intentionally introduced into a package by an attacker, almost never the maintainer, and it will always end badly if you ship malware to production. You don't have a few days or weeks to mitigate the issue. You need to catch it before you install it on your own laptop or on a production server. Unfortunately, the common security wisdom these days is to always try to stay on the latest version of a package. This is generally pretty good advice, and I know where it comes from. It comes from a good place. Unfortunately, it only increases the risk of supply chain attacks. Because the quicker that you merge a Dependabot PR like this one here, the fewer eyeballs that have had a chance to look at the code first. You can't benefit from herd immunity if you're the first person to catch the virus. So how quickly should you update dependencies? This is a question that we struggled with on our team. On the one hand, if you update too slowly, then you expose yourself to known vulnerabilities. These are vulnerabilities that everyone knows about, and if you're running this code in production, it's only a matter of time until you're hit. On the flip side, if you update too fast, then you actually expose yourself to unknown vulnerabilities. These are bugs introduced unintentionally by the maintainer in a new version that you would actually have not been vulnerable to if you just stayed on the old version. Not to mention that you expose yourself to malware that's been added to a package and that no one has had a chance to discover yet. So this is just an irreconcilable trade-off. It's very hard. Now you start to see why this is a hard problem. And my colleagues and I building Wormhole got really curious about this problem. We wanted to solve it for ourselves. We wanted to see if there was something we could do to protect our users from software supply chain attacks. And so we went and downloaded every package on NPM. We spent a few weeks poking around, and now I'm going to share with you what we found. So first off, just some stats. NPM, all of NPM, just the metadata, takes up 100 gigabytes. Then when you add in the package tarballs, you get up to 15 terabytes. And so now let's talk about what we found. So let's talk about malware. The first thing that we learned is that most malware is in install scripts. We kind of knew this already from one of the papers I mentioned earlier that found that most malicious packages, 56%, start their routines upon installation. The number on NPM is actually 64% because of how NPM allows packages to run arbitrary code at install time. So this is a feature that's missing from other package managers. But unfortunately, install scripts have legitimate uses, so it's really not a viable solution to just disable install scripts. So now let's take a look at some actual malware. This is a real piece of malware, and all the examples in this talk were collected from NPM in the last 30 days. So this is all really real and really fresh. So what does this package do? This is the package.json file in the package. And let me draw your attention to the pre-install script here. So this is a script that's going to run upon installation of this package. And what is it doing here? Well, it's running 3 separate scripts, all in parallel. They each try to exfiltrate data from your system in various ways. So let's take a look at one of the files, the index.js file here. So this is a pretty straightforward exfiltration attempt. They're connecting to this IP address and this domain, which is attacker controlled. And the data that they're sending is the process.env object, which contains all the environment variables. You know, the secrets, the keys, the tokens that you might have in your environment. And then it stringifies it and bufferifies it and then just writes it to the request. But then there's this other file, dns.js, that we saw was also being executed. This file is interesting because it attempts to send the same data to the attacker, but over DNS instead of HTTP. And you can see that here in the way that it's using the DNS package. Here they're setting the servers, the DNS servers, to their own IP address. And then they're grabbing the process.env object again, and they're encoding it and preparing it to be sent. But the way they do it is they put it in the DNS hostname. They just send a DNS request to this non-existent hostname, and that's the way they get the data out of the system. So why do this? Well, it turns out that a lot of people are running firewalls or systems in production that attempt to block connections to unexpected IP addresses and host names. And a lot of those operate on HTTP and the TCP level. But if you use DNS, you can avoid blocking or avoid detection by those tools. So this is sort of just another attempt to get the data out. Here's another example, though. So this is the one I mentioned earlier, UA Parser.js, which has 30 million downloads a month. This attack affected many organizations, including Facebook. So let's take a look at the code. So here we have the package.json file. And you'll notice it's also using the same pre-install script technique that I mentioned earlier. And it's running this file preinstall.js. It's doing it in a couple ways here. It's doing it using this start command with this /b flag, which is just a way on Windows to start up a script in a new hidden terminal window, which makes it a little bit more sneaky. But let's take a look at the actual script here. So this is the preinstall.js script. The first thing you'll notice is that it's doing a different code path for each platform. Lucky Mac users, nothing happens for Mac users. It's just the no-op. But on Windows, it spawns the command prompt and runs a preinstall.bat file, which is basically a shell script on Windows. And then on Linux, we run this function here, which just runs a preinstall.sh script. So let's take a look at what's going on inside of this preinstall.sh file. It's pretty interesting, actually. So the first line is a curl request to a geo IP service, which returns the country that the user's IP address comes from. Then they follow that up with a grep, which looks for very specific country codes. In this case, Russia, Ukraine, Belarus, and Kazakhstan. And if there's a match, then the script returns without doing anything. Next, it looks to see if the malware is already running on the system by using pgrep, which searches for running processes. If the malware is found to be running already, then it returns. Otherwise, it downloads the malware using curl or wget, sets it to executable, and then executes it. And based on the command line flags that you see here, you can tell this is a Monero miner that's mining Monero cryptocurrency. So, that's kind of annoying to have your computing resources being used for this, but it turns out that Windows users were even less fortunate, because the script that runs on Windows, it starts off the same in that it downloads this Monero miner, but it also downloads this extra DLL file here. And what this DLL file does is actually searches the system for passwords and other credentials that it's going to steal. You can see down here where it actually runs both the cryptocurrency miner and registers the DLL file to run. And so this attack stole passwords from over 100 different programs and the Windows Credential Manager. So yikes, this was like a really bad one, and not to mention it was added to package with so many downloads that were used by so many big organizations. So now that we know how attackers can run their payload, how do they actually get people to install it in the first place? Typo squatting is the most common tactic. This is what we learned. Here's an example that we found. So these are two packages. One is real and one is fake. And you'll notice the names are very similar. They use proxy versus proxied. And so it's very likely that somebody might type in the wrong name here and install the fake package. So what does the package do? You'll notice the package.json uses an install script again. This time it's a post-install script, but it's the same idea. And if you open up that file, you'll find that it's completely obfuscated. And we spent a few minutes looking into it, but we haven't been able to figure out what this does quite yet. But even without knowing exactly what this code is doing, you can bet this is not something that you want running on your computer or in production. So typo squatting is pretty common. This is actually like the main way that people try to get unsuspecting people to install packages. The next thing we learned is that dependency confusion attacks are also really common. And they happen when a company publishes packages to an internal NPM registry and uses a name that hasn't been taken yet on the public NPM registry. Later, an attacker can register a package with the same name and then put malware in it. Then internal tools will later get confused and use the public version of the package instead of the internal one. So this is why it's called a dependency confusion attack. Looking through the recently deleted NPM packages that were deleted for security reasons, we found a bunch of likely dependency confusion attacks. Most of these had malicious code in them. And all of these packages had names which appear to conflict with likely internal package names inside various companies and organizations. So here you can see Yahoo, URID, which is a registry manager for the EU, 18F, a US federal agency, Palantir, a government contractor, DuckDuckGo, Shippo, and you see the names of all these packages look like they conflict with internal package names that might be in use. There's a whole bunch of these. I'll just show you another set of them, but there's really just tons of attacks along these lines. There's targeting Wix, Unity, and Grubhub in this case here. So my tips for you regarding this are to check your internal tools and make sure that they're not accidentally fetching from the public registry instead of the internal registry, and monitor new NPM packages for your company name. And then another common thing that we noticed when looking through our trove of NPM packages was that code on GitHub often differed from the code published to NPM. This was really common. And this makes sense because most people will go to GitHub if they want to look at the code, and the code on GitHub will look perfectly fine. And NPM does not guarantee that the code on GitHub matches the code published to NPM. So why don't we ever look at the contents of a package before installing it? It seems like that would solve the problem. I think one big reason is that NPM does not make this easy. If you go to the NPM website, they have this Explore tab, which has been there for a few years, but if you open it up, it just says that this feature is coming soon or that it's exclusive to Teams. So it's not really making it easy for you to look at the contents of a package. So given that, what do you do if you actually want to inspect a package before you decide to add it to your project? You have one option, which is you can go to GitHub and just hope that the code there is the same. But the most common thing you might do is just try to install it. And as we've seen, that will run the install script, so that's not a good idea. So a pro tip for you is if you want to fetch a package to evaluate it, I recommend you turn off install scripts using the -- ignore scripts flag, or turn them off globally using this global config setting. So to summarize, this is really just the tip of the iceberg. I've shown you a few malware samples. I've explained a few types of attacks. But we saw 700 packages removed for security reasons in just the last 30 days alone. And these are just the packages that we've caught. There's a bunch that the community hasn't caught yet. And so, this is a really pervasive problem, and this is something that is going to only get worse. So given that, what can we do about all this? What's something that we can actually do to improve the security of our projects today? And now I'm really excited to share with you an early preview of a new tool that we've been building that helps you protect yourself from supply chain attacks, as well as evaluate the quality of packages. It's a pretty early preview, so it's a little bit rough, but I hope you get the sense for how a tool like this could be powerful in the fight against supply chain attacks. The plan is for this to be free for open source, and then to offer a paid plan for companies. So let's take a look at how it works. Here you can see a package page for the RimRaf package. One of the first things you'll notice over here is these package scores that evaluate the package on various dimensions, from supply chain security to overall quality, to maintenance, to known vulnerabilities, and to the license. And if you hover over each of these, you can see the various factors that go into creating each of these scores. And because this is an early preview, we're still tweaking the weights here. So these will improve over time and become more accurate. The next thing you'll notice is this very prominent warning here that this package accesses the file system. Now, given the purpose of this whole package is to delete files, this probably isn't too surprising. However, we show this alert anytime a package accesses the file system. So on certain packages, this may raise red flags. We can click in here to see exactly where the FS package is used, and we can look through this file to get an idea of what it might be doing with the FS package. The other thing that's nice is we can click here and go up to the root and see all the files that make up the package. Since this is open source, it makes sense that we should be able to view the source easily, and for the first time we can. The other thing that's nice about this file explorer is it makes it really easy to evaluate potential malware without putting the files on your system and risking accidentally executing them. Let's take a look at another package. This is a page for buffer-util, a package that helps with various buffer-related functionality for the WebSocket package. So this package is actually made up of native code. And so what we see here is two warnings around the fact that this package contains an install script and also that it contains native code. So it uses the install script to actually compile this native code, which is not too surprising given the purpose of this package. But notice that we see this up front, and we're fully aware that we're about to run native code and run an install script when we install this package, which is very helpful. It's benign in this case, but it's good to know about. We've actually caught real malware with this and gotten packages removed from NPM. And so we've had some success getting packages taken down, and hopefully there'll be more soon thanks to this new visibility into what packages are doing. Let's take a look at another package. So this is a package that provides native bindings to this low-level C library called libutp that is used in BitTorrent. And you'll notice here that, as we expect, there is going to be an install script and some native code, and also we access the network as well. So if we click in here, we can see exactly what type of networking is being used, and you can see here that the DNS package is used to do some DNS lookups in this package. But here's another example that's a little bit more surprising potentially. So this is a package called Angular Calendar, and it's a calendar component for Angular. We wouldn't expect a package like this to talk to the network. So if we go into the Issues tab here, we see there's actually several issues. Down here at the bottom, I'd like to draw your attention to all of these issues that are being caused by this package called scarf/scarf. It contains install scripts, it accesses the file system, it accesses the network, it accesses the system shell, and it contains fragments of external URLs or IP addresses. So right now, lots of alarm bells are going off in my mind, and I really want to know what's going on with this package. So if I click in to learn a little bit more, we can see what may be going on here. So here we see that in this dependency, the HTTP or HTTPS package is imported. And if we grep around, we can find a little bit more info about what this package is doing. This is actually a benign analytics script that helps the open source developer to fund and maintain their project. And it sends basic system info back to this service so that the maintainer can figure out where their code is being used. You should know if you're installing a package that is communicating with someone's servers. It's a pretty important detail when deciding what package to use or whether an update is safe. And the presence of an IP or domain strongly suggests exfiltration, especially with certain attacker domains and IPs. We've seen lots of malware use this to exfiltrate data. In this case, it turns out that it was benign, but it's still good to know about so that you can make an informed decision if this is a component that you would like to use in your app. Let's take a look at another example. Here's a package called Browserify. This is a typo of a popular package called Browserify that you may have heard of. And here we see that we're being warned that this may not be the package that we want with this prominent warning right here. It helpfully suggests that Browserify may be the package that we intended to install because it has 48,000 times as many downloads as Browserify. If you use our soon-to-be released compare tool, you can actually see exactly what the differences are between Browserify and Browserify. And it turns out that Browserify injects extra JavaScript into your bundle, which doesn't sound like a good idea. Here's another example. Here's a package called BrowserList. Here we see that this is a typo of a package called BrowsersList with an extra S in there that is downloaded around 3,000 times as often. And if we go into the versions tab here, we can see that in the past, there was malware hosted here on this package name, as evidenced by this security holding version right here. And now it turns out that the package is actually just a helpful message that tells you that you've made a typo. But in the past, this used to be malware. And so it's probably best to fix your project if you're depending upon this package because it's not the right package. We've actually found that the Preact project was using this package by mistake. So even high-profile projects are susceptible to installing the wrong dependency and not noticing it for weeks or months. And then finally, I want to show off this version diff feature that we have. This shows you all the changes that happened within each version. In this case, we're looking at the debug package here. And here we can see that a dependency was updated in this version, and the total number of dev dependencies was reduced in this version, which is a nice improvement. Here we can see that in this version 3 years ago, tests were added for the first time, which is good. We can also see other various things. Like in this case, eval used to be used, but it was removed. Here we can see a CVE was fixed, which is nice. So you can see a high-level overview of what changed in each version. On top of that, if you click into this page, you can get a detailed diff of exactly what changed in that version. So here we see that a full diff of exactly the lines of code that changed in this version, and there's no secrets, there's no hiding what actually changed here. And finally, I'd like to show you this really cool malware tab that we have. So this is a place where you can look at malware samples that we've collected. So these are all packages that were removed from NPM for being malware. And we have copies of them here that allow you to look at them and learn from them and see what the malware may be doing. And we're actually using this to build our detections to catch future malware. So if you look through here, you can see, for example, there's a package here pretending to be something to do with Medicare. And if you click into it, you can see it's using an install script. And then if you go up to the file that it's doing, you can see it's a typical HTTP-based exfiltration. So yeah, I hope you enjoy this tool that we've built. We're also working on a GitHub app to bring this powerful data directly into the developer workflow. So you can block dangerous dependencies in CI. It finds things like typo squats, high-risk packages, as well as updates, which add significant new behavior, such as install scripts, network, or file system access. And it's configurable. So you can have it just leave a comment if you'd like, or you can have it require explicit sign-off from the developer who sent the pull request or from the team lead. I'm really excited about how this is going to be able to help the community to write more secure software. You can give it a shot and try it out at socket.dev. Please, if you give it a shot, please send your feedback to me. I'd love to hear from you, and I'd love to know what you think. Thanks so much. Have a great day.
All right, and thank you, Feross. There's some really good discussion going on over on your AMA on the Discord. I saw like 4 or 5 people typing at once. Everybody's really triggered, to say the least. Now, this tool you made looks really helpful. How do you envision developers using this information?
Yeah, that's a great question. So obviously, we have the package search website, which I demoed. That's a great first start when you're looking into a package to understand what capabilities it uses. Does it read files? Does it talk to the network? Does it run an install script? Does it have native code? Is it potentially a typo of a more popular package? So that's what that tool is that I demoed, and that's great. That's kind of what we see as the first step toward getting this information out there about what packages are doing. And what capabilities they're using. But I think the more powerful way to use this information is actually something that we're going to be releasing in the coming weeks, which is a GitHub app that you can install into your repo or across your organization that can actually provide that same type of information, but right in line, in context, when you're making a decision about whether to merge a pull request. So if someone on your team adds a dependency or updates a dependency, and you're looking at that pull request and you're trying to decide as the reviewer, what should I do? What is this dependency actually doing, right? What is this version bump actually bringing in? Is it bringing in malware, or is it bringing in completely new capabilities, such as talking to different domains on the network? We can tell you that right in line in the pull request with a comment from our bot, and you might even be able to kind of configure, do you want this to actually block the pull request until someone reviews it, or whatever kind of other behavior you might want. So that's kind of the way we see it being used in the end.
All right. So how can people stay in the loop and find out when this GitHub app is released?
So we posted the URL socket.dev. That's the website. That's the place to go to check it out. And there's a little mailing list button where you can put in your email, and we're going to send everyone an email in a couple weeks when that's ready, so that they can install it into their GitHub apps and get the protection in real time on all their pull requests and dependency changes going forward. That's definitely the best way to get in. And we also have a Discord. I just posted a link to that as well on the website. So if you see the Discord link there in the header, you can click that and chat with us right now. We're really excited to hear what people think, because we want to make the community more secure, and we want all of open source code to be something that people can trust and rely on. And I think supply chain attacks are really just putting that at risk. And so, yeah, this is just, I think, something that the community will hopefully find very useful and helpful.
All right. So thank you so much, Feross. And that's going to conclude our talks. Before I hand over to Carter for the farewell, a moment for my own plug. I'm giving a talk on using humor in talks and blogs at DevRelCon next Wednesday, November 10th. I hope you'll all watch. Also, you can follow me on Twitter at LetMyPeopleCode, or connect with me on LinkedIn, because I'll be posting more about that as we get closer. And now, a lot of people help make CascadiaJS happen, but the constant has been our fearless and hard-working leader. So let's all start a round of applause wherever you are and keep it going. Carter, over to you.